Okay, I think we'll get started. Hi, everybody. I'm Dave Jones. I'm the co-chair of the Disaster Lifecycle Cluster for ESIP. And Maggie Glasgow, who's online here, is also the other co-chair. We are going through an evolutionary process for the Disaster Lifecycle Cluster because the last few years we've been focusing on wildfires. And what we're going to be talking about today is opening doors to open science and end users. And so welcome to everybody that's online. We appreciate you connecting. And just to let you know, it's pouring down rain here in Burlington, Vermont, but hopefully that won't lead to any more flooding in the area, although we do have a flash flood watch in effect for the remainder of this afternoon into this evening. So the first thing that I want to do is advance the slide. There we go. We're going to be taking some polls. And so if you connect to the Slido with your phone, I will switch over actually. Are we sharing the whole screen of the computer? Like when I bring the Slido poll up?
Yeah, I can see it.
Oh, you can. Okay. So let me see. Where is that Slido poll? Do I have it up anywhere? Nope. Sorry. Yeah, you can connect to it, but it is, hopefully it's launched. Let me check on my phone.
Do you need me to, do I need to put like present? Is that what we need to do to?
Yeah, I think so. If you can present it.
Oh, no, I mean, all that does is, let me, I don't want to do that.
The first one is up. It's how are you feeling about ESIP? And
Okay,
so
awesome. Yeah.
So just enter a word, however you feel. I mean, I know you've gone through a lot of Slido polling and, we're in the first day of ESIP. This is the last session, I guess, before we end the sessions for today. But just let me know how you're feeling about ESIP. And you can type in happy, awesome, sad, great. And I can see the now, I thought Megan had opened in the browser tab that we can
If you pull it over. Maybe she didn't open it. Oh, I see. If you go to
the link.
the Slido on top of the Kiko chat, like there's agenda and then there's a tab that says Slido.
Yeah. Oh, here we go. And then you can say present. Yeah.
Yes, there you go.
Awesome.
Yay.
Yeah.
Technology works.
Mahalo ESIP. I know who said that, I think. That's great. Awesome. So I'm gonna let I'll give you another minute to just put in how you're feeling about ESIP, because it's so exciting. I mean, for me to be here to get in with a whole bunch of data discussions. You don't really have many meetings where you can focus the entire meeting on conversations about data.
Dave, if you just let me know when you're ready to close the poll, I'll hit stop.
Okay, we can close it. That's great. And then the next thing that I want to do is just give you a few. This is my niece's baby, by the way. He's joining from Los Angeles remotely. He's very excited about it too. So for those of you just online, please mute yourself if you're not talking so we don't hear any background noise. Feel free to turn on your camera if you have questions that you'd like to ask. And please connect to this QR code and sign in. This is the Google Doc that you can connect to, and then enter your name, email address, things like that, so we can keep in touch with you. We keep all of our records for the Disaster Lifecycle Cluster open so everyone can see what we've done over the last couple of months and years of evolution that we've had going on here. And then if you have questions online, please ask via the chat. And then we'll move on. So if you have the QR code, thumbs up when you have them in the room here, and I'll just keep it up here until you get it. Good. Hopefully it takes you to the Google Doc. Yeah. Okay. Awesome. Okay. So that's what we'd like to know. Who is here? The Disaster Lifecycle Cluster really covers all types of disasters. As I mentioned in the past, we focused on wildfires, and Karen Moe, who's here in the audience, was my co-chair for many, many years, 12, 13 years, long time. And we focused on wildfires and getting trusted data from wildfires. But ESIP has formed a wildfire cluster, and that session will be on Thursday morning at 8 a.m. To talk about what we're doing there. But why are we here? I had the opportunity to review this House Committee on Science, Space, and Technology, which was last week. And I hope you can hear this audio, because this is a video of a congresswoman asking a question of the witnesses about data. And I'd like you to watch this.
Let me just get one more quick question for anybody who has an answer. The Wildlife Fire Risk Reduction Act is being reintroduced, and it asks the federal government to play a coordinating role. I was at a very interesting discussion at NASA Ames several months ago with federal agencies, local agencies, academic, including San Jose State, as well as private sector. And one of the issues that they identified was that we don't really have a way to distribute even the data that we have, put aside the data that we're missing. Do you have thoughts on how we might better coordinate the distribution and the standards for which the data is distributed? Any of you?
Sure. I think federal collaboration on development of new standards and data platforms for the distribution of this data is very important. A lot of that's happening at the state level right now. I think that's a place where NOAA could do very well to build some new platforms and data standards around that type of information, because there's really not a federal standard for that currently.
So who thinks we need new standards and new platforms to share more data? I was cringing when I saw this. And these are questions that our lawmakers are asking, that they don't have a clue as to the fact that ESIP exists, and they don't have a clue for what everyone in a bunch of science agencies are doing to make their data more available and share it. So I forwarded this video over to Susan. I edited it to just make it that section. But let me see, I'll get out of this here and go back to my, oops.
There's one simple hearing hack anyone can use to improve their hearing almost overnight. Did you know that hearing impairment?
Yeah. Sorry. Oh, great. Okay, thanks. So what I did was forward this to Susan and say, you know, a great role for ESIP could be to help further educate congressmen and senators on what's happening with data collaboration, interoperability, and things like that. So I think it would be pretty awesome to have folks within ESIP or members within ESIP to monitor some of these hearings and say, hey, you know, there's more information that could be provided to this congresswoman or congressman or senator to further bring them up to speed for what's happening. Yeah. We need a microphone to you, and just introduce yourself as well. Have a little discussion going already, which is great.
Yeah, so this is Jonathan Blythe from the Bureau of Ocean Energy Management. And my question is whether it was the response you take issue with, like you said, we don't really need new standards or we don't need new portals. But the question I think was still valid is, are the data accessible? Are they available? And I don't know what the answer is for fire data, but I think that's probably a valid concern.
I'm sure it is. I'm sure it is a valid concern. I mean, would everybody in the room agree that we have trouble distributing the data that we have today? I would say yes. And then with other data that's coming down the road and even more quantities, you know, it's probably even tougher. But there are efforts underway that wasn't pointed out, you know, within the federal agencies to make data more available, shareable, findable, you know, all the fair data principles. That's all I was pointing out. I think the witness there was a private sector CEO who didn't really know a lot of stuff going on with data sharing and things like that. Yes, Rama. Yep.
Oh, yeah, this is Rama from SSAI and NASA. And I was going to say, in relation to the comment that you were making about informing the congressional people and other people, that it would be good to invite some of those people to these meetings once in a while.
Yeah. Yeah, it would be great, actually, wherever ESIP goes, to invite the local representatives.
Yeah.
I think of that state and that district, I think would be phenomenal.
Yeah, I think in the past we have done it. When we had the meetings, in the winter meetings used to be in DC. It was convenient for the local politicians and whoever officials to be brought in.
I think that's one of the reasons we had the meeting in
Exactly.
Washington in January, so they could
Exactly.
get to it. Yeah,
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 if they could get in the ice storm and so on, yes.
exactly. Right behind you, Rama, there's a question, and then we'll.
Hi, Zhong Liu from Justice. I think we need services, especially for smartphone market. Think about that. How about the Congresswoman has a smartphone and install the NASA app? She can easily get the data in her district, automatically monitor her district. That would be great, right?
That'd be wonderful. Every congressman and senator.
And send a notification, just like your home monitoring system,
Yes, yes. No, I agree. There's a question over here. And just please identify yourself.
Oh, yeah, I'm Hannah Ake. I'm with the state of California. And I was just going to say, point well taken, that I think like the federal government has data online. It's available. I would say it's more easily accessible than a lot of state agency data sets and local data sets. And a lot of the wildfire data was being collected by local agencies. But if you're looking for that, you don't really know where to find it. It might get ingested to a federal portal at some point, but if you're looking for on the ground kind of smaller scale, real-time data sets, those aren't really available to people like this. So.
Yeah, no, that's true. That's a really good point for state and federal data sets. They're tough. And, this is the point, and I'd love for you to just raise your hand if you have questions or you have comments, because this kind of session, and Karen and I have been working on this for a long time, and Maggie, who's joining my co-chair remotely, we're really focused on identifying trusted data sets, making them easy to find, which is difficult for people who don't work with data. People who just want answers don't want to dive into the pixel values of every retrieval that's in the imagery. They want answers, and they have to make these decisions quickly. And so we have a couple of other questions that we're going to do in the Slido poll again. And Maggie, if you could launch that poll, I think you can do the little QR code again to get that code. What sector do you work in? So this is just a kind of a sampling of folks in the room. What sector do you work in? Is it researcher, data manager, communication, developer, education, or other? And send that in. And I'll click on this link to see if we can monitor it. Is it that one right there? Okay. There we go. Awesome. And I would say that about, I mean, my job is, I'm CEO of Storm Center Communications. We work very closely with decision makers to put more science data to use, to educate them about how they can use data and how it can help their operations and decision-making, response activities and things like that. The majority of people that we end up working with have no idea that there's federal government data available for them to use. So they don't even know where to start looking for data and don't even know the questions to ask to even start finding data. So a lot of data managers in the room. That's great. Some researchers, communications, and some other. That's about 18 of you. So if you, I'll give it another minute to see if the poll changes at all. And then there we go. There's some other input. Excellent. Okay, Maggie, you want to move to the second one? You can close this one out. Okay, great. Or the third one. How much of your day-to-day job can be applied to disaster management? And it's not strictly like an emergency manager, but just how many of you, or how much of your day is dedicated to making sure data is available to be accessed by responders, emergency managers, internally, externally, things like that. Let's see, 50%, 10%. And I would imagine with the need for data access and data distribution, that these numbers would probably be going up, particularly for data managers. 80%. There's an 80%. Okay, that's a good indication. All right, Maggie, let's go to the next question. 75%. Okay, the next question.
David, or sorry, Dave. I think the next question will be after Greg's presentation.
Okay, thanks, Maggie.
Mhm.
That sounds good. So I just want to give everybody a quick background in case you haven't been to a disaster lifecycle cluster meeting or one of the sessions here at ESIP. What we were doing in January of 2021, we had a session on California burning, putting data to work. Where does data come from? Where does trusted data come from that can inform not just responders, but residents, people? There are a lot of apps out there, a lot of individual websites people can go to, but where do they trust to go to get that information? In the July of 2021, we talked about the ESIP ecosystem of innovation, where we can take data from web services, web service formats, KMLs, CSVs, put those into the disaster lifecycle cluster and then make them available to users, to actual users, to provide feedback. Hey, is this data useful for you? We have this data from NASA, this data from NOAA, and it goes into the All Hazards Consortium, which has 45,000 members who can give us feedback on whether or not this data helps them move trucks across the country, deliver medical supplies on time, reroute their traffic because of storms or things like that. And so that proved to be quite successful and a great model for ESIP in being able to input data into this ecosystem of innovation and then provide it to whether it's DHS or NOAA or the Forest Service or the Weather Service or the state of Florida. And then in January 2022, we talked about the wildfire in general, and how we can create this plan to address pre-wildfire, during wildfire, and then post-wildfire activities. And so January of 2022 was the pre-wildfire. In July of 2022 was during wildfires, what kind of trusted data access is out there. And then in January of 2023, we started to pivot because we started the wildfire cluster. We said, wow, the disaster lifecycle cluster is focusing on wildfires for 2.5 to 3 years. Let's start a wildfire cluster and just focus on that and keep the disaster lifecycle cluster going, but expand it. And so those of you in this room are the ones that can speak up and say, here's what I'd love to do, or here's what I'd love to see the disaster lifecycle cluster do, so we can get more trusted data available. If you're working on projects that you think could provide valuable information, we want to know about it. Is it something that could be advanced research? Is it something that could be put to use in a prototype fashion where we could put in front of some people and provide feedback? These are some credible services, I think, that can be delivered. And so this is a bigger look at that ESIP ecosystem of innovation, where we have the disaster lifecycle cluster. Whether you have a widget, it could be just taking a map. It just could be taking some data layers. It could be taking your web services and putting them in here, and then saying, hey, this might be valuable. We think this data set might be valuable for a state emergency manager. Well, we can put that into the All Hazards Consortium. I'm on a 2-hour telecon every Friday morning with DHS, FEMA, the food, fuel, logistics, transportation, communication with AT&T, Verizon, and Comcast every Friday for the last 8 years, for 2 hours, talking about challenges that they're having in accessing data, understanding data, where they can get trusted data from. And so this is a great model for putting things in front of them. And then we started to look into communities. How could communities take advantage of data, not the science data sets so they can do some analysis, but some data sets that could give them good information on where is this flood? How deep is the flood going to be? What's the forecast? Where is the wildfire? Where's the, where are recovery efforts going on in my area? And that is something that the disaster lifecycle cluster is very interested in. So we want to address real world use cases that ESIP clusters can address and put to use and test in these operational environments. This is an example. One of the integrations that we did with GeoCollaborate, which connects different people on the same platform at the same time, so you can all be looking at the same data, is integrate NASA's CDAC socioeconomic data. So you can freely draw a circle around any area of weather watches or warnings, and then that sets off a command that goes right to CDAC and pulls in the population information from 2000 to 2020 and shows how it's changed. And that graph is shared immediately on everybody's device in their mapping environment. And so this is something that has worked over the course of time, and something that even NOAA and the Weather Service are quite interested in when they talk about impacts from landfalling storms, hurricanes, things like that, so they know how many people are being impacted and affected. There are diagrams and graphics that can be shared in real time, whether they're flooding after a fire for burn scars, whether it's some dangers caused by high ocean waves because of storms that are generating high winds. There could be infographics and things like that that could be shared within the collaborative environment. And the National Weather Service is now standing up a lot of their web services as a cloud service. They're porting everything over. They've stopped their internal serving of web map services, dynamic services, feature services, and they've ported them to the cloud now. So this is an operational agency, the National Weather Service, who now has a web page where you can just type in NWS GIS and then say, click web services, and you'll get all those services you can input right into your mapping environment. And these are the type of services that we need to see from other agencies. I don't know how many ESIPs, well, I've been to the very first one and all the way till this one. But how many times we talk about what we need in these services and everybody says, yeah, you're right. Yeah, we see them. We don't see them show up. So we really need to have action in anybody who serves data to think about web services. It might not be what you would suspect or what you would see as science data, but it's enough data to help people evaluate their situation and make decisions. And you can always direct them to find the data in higher details. Yeah, Jonathan.
So I don't know, I think I copied you on this, but the Discovery Cluster, we interviewed Nelson Boz from the National Weather Service. He's the warnings coordinator for the New York region. And the reason we were interested in discussing it with them is because they have a really good customer focused workflow for forecasting earth science data analysis. So it's not necessarily that Discovery Cluster is interested in the mission space, but they seem to have solved some fundamental problems around delivering earth science data. And you're pointing out the same issue here with their web services. So yeah, anyways, just do you have any other thoughts? Like now they're starting to serve, they have a new line of business where they're during an event or, you know, that they're working with the utility companies locally and informing them about the latest forecasts and scenarios so they can better respond to the weather event. So I'm just curious if you followed up on that.
Yeah, we work with the utilities all the time in our all hazards consortium calls, and the Weather Service actually doesn't support utilities directly because there's some utilities hire their own meteorologists, they have their own weather departments, and private sector companies support the utilities as well. And interestingly enough, the Weather Service has what they call core partners. And those core partners are people who are responsible for saving lives and responding to disasters. So like FEMA, state emergency managers, those kind of folks, they support directly and brief often when there's chance of flooding or hazardous weather. But utilities, they don't do that. But they do make their services, their web services available so they can be delivered into those utility systems. And then their own meteorologists at those utilities can provide the guidance to tell them what they should or shouldn't do. And they also go beyond that. The local meteorologists in the utilities forecast high temperature and low temperature and wet bulb temperature very precisely so they can set the power generation levels accurately for each market, right? If somebody says, hey, it's going to be 80 degrees and it's 95, the power company is underproducing power and they're going to have to buy it from somebody else on the grid. So they don't want that. So weather forecasting is critical for utilities. But the Weather Service is taking, and I've been working with them for a number of years to really encourage the web services. And think about this from a NASA perspective, from Earth science perspective, those of you who are serving data and producing data, think about your data as another layer that could supplement real-time data overlaid on top of it. Okay, so many times I've worked with NASA or I've worked with, USGS or NOAA, and they're all thinking of their own data, which is fine. That's what they're funded to do. You have to think of their own data. But the power comes in the integration of multiple agency data sets, of state agency data sets, and even some private sector data sets that are doing value adding or applying some AI that can really help. But it's all the data together. It's not just one agency that is solving, that can solve a problem. And over here, notice this on the right-hand side of the screen, all the air quality web services that are now available. And with all the Canadian wildfire smoke and smoke from the Western wildfires that are impacting health so terribly in the United States, we're now able to pull in the HRRR, the high resolution rapid refresh smoke model, and show where smoke is at the surface, and then the vertically integrated smoke throughout the atmosphere. So more web services is something that's very good. And in the wildfire meeting on Thursday morning, we're actually going to sit down and we're going to charge everybody to find trusted web services. It's going to be a roll up the sleeve, hands-on kind of thing. And we're going to say, you go to the Forest Service, you go to NOAA, you go to NASA, and find me a list of trusted web services. And I think we're going to find some challenges in that area. So this is what we would love to do. The other thing that we talked about in the disaster lifecycle cluster, as a matter of fact, just last meeting that we had just 2 weeks ago, we had our telecon Zoom meeting. Phil Balin from FEMA and the National Guard in California. He got on, he said, you know what we'd like to have? We had a meeting with state agencies and local agencies and federal agencies, and we need a status of what kind of data is being collected and where and when. And we need that visualized in a geospatial layer. So we can click on it and say, we know we're going to get this imagery at this time, and here's where it's available. Or here's all the imagery available. What type is it? There is nothing out there that can show the status of collected imagery or data when you're talking about responding to a disaster, wildfire, anything like that. Rama.
I think in addition to what data is being collected, it would also be useful to have what's being done with those data and what kind of products are being made and when will they become available.
Yes. Yes, I agree. I agree. A question online in the chat. Yes.
This is from Peter McHarry, hope I'm pronouncing that right, but NASA satellite data integration with other NRT layer would require changes to latency requirements of the producing systems. Are there priorities for particular data that would need NRT?
Yeah, I'm sure there are priorities for various NRTs, near real-time data. And there are priorities. And when Phil in our call a couple of weeks ago said this, it kind of hit me like, wow, this could be a nice charter for the disaster lifecycle cluster to focus on for a while. I mean, look at all of you in this room and your expertise. And if we put our heads together to say, okay, daggone it, we know Civil Air Patrol in my state's going to fly. We know they're going to collect this. Let's create a geospatial layer and make it available in this web service. And NASA, you're flying a lot of satellites out there. Here's when Landsat data, that's more USGS for USGS and DOI are flying Landsat over. Here's when this data is going to be available. You know, we know this hurricane is going to make landfall. Here are the data sets that everybody wants. You know, and here's when they're going to be available. I'll share with you. We've done quite a few interviews with data analysts in various agencies, and basically the bottom line number that just strikes me as amazing is when an analyst has to access imagery and data to do their job, they spend 80% of their time, 80% of their time on shift looking for data, just looking for it. 10% of their time being able to look at it and analyze it, and 10% of their time briefing it out. What if we could turn that on its head and say 10% of the time because subject matter expertise is out there working for them out here somewhere, identifying where data is going to be and when it's going to be made available, and they can just click on it and use it for their job. Rama?
Question. I was wondering if this cluster could take on the task of identifying certain types of disasters that we need to worry about, and which data sets from which agencies are relevant for them. And such a compilation would be a useful thing. And the next step after that compilation would be to do what you're talking about, namely producing real-time GIS mapping of those pieces of information.
Yeah, that's a good suggestion. I would throw that out to the group because, you know, ESIP is driven by the community. The community created the disaster lifecycle cluster. And it's that community that's going to define what we want to focus on. I thought it was striking when Phil participates in the disaster lifecycle cluster fairly frequently. He's a busy guy. I think he's out at the Esri user conference this week. But he said, listen, when I can participate, I will. And these are requests. Nothing like this is happening, and it's going to take a community to put it together. And he said, ESIP seems like that kind of community. And I agreed with him. So I think it's something that we have such reach into all of our organizations that it could come together, even if it was for just a couple of data sets. And I remember being a part of a NASA funded project years ago where we were working with the state of Texas, the Southern Region headquarters of the National Weather Service, and FEMA Region 6. And we looked at a hurricane 168 hours out from landfall. What are your data needs? 120 hours from landfall. What are your data needs? All the way to landfall, and then landfall plus 48 hours. What are your data needs in the response, monitoring, response, recovery, you know, because then it gets very high resolution, you know, damage assessments, things like that, flooding levels. What are the flood inundation models saying? Things like that. And I think we could probably put something like that together and then maybe ship, you know, say, okay, who's responsible for this? How can you make it available? But it really does take a lot of focus. And certainly, I think this cluster could attack something like that. Yeah.
As far as NASA data are concerned, the NASA near real-time data that's produced by LANS under USDIS would be a good source of list of things that are already available in near real time. And they're being driven by certain operational requirements that have come from committee meetings, many group meetings like this.
Yes, right.
It's that there is a LANS user working group that makes the advice.
Sure, and I think the output from this cluster could be great input for Lance.
Exactly.
You know, and that committee and that group, the users working groups for all the, you know, different DACs and things like that. I do think that, you know, if somebody comes to us and says, hey, we're going to have to change our requirement, you don't have to change requirements. Just listen to us first.
Yeah.
You know, just listen to what we want to bring to the table and say, you know what, you might not have data that's updated every 30 minutes, but you have data that's valuable in a time frame that people could access it and use it. They just can't get to it because they don't even know about it.
Yeah, there should be analogs of that for in other agencies as well.
Yes.
Who also could get inputs from this cluster.
Yes, exactly. Right behind you, Rama. You can pass the ring.
I think there are a lot of, right now it's a good timing because there are a lot of talks about analysis ready data. So basically you have a operator and the user provide the requirement and the user, you know, make an analysis of ready data, you know. Yeah, on the fly, you know.
That's right.
That I think that's possible, you know. We just need to put together the requirement for products.
Right.
You know, yeah. For example, I can give you an example. You know, iMerge is half hourly. You know, some people they don't want a half hourly, they want a 3 hourly, 6 hourly. So this can be fit in, another ARD, right? Analysis ready
Ready
data.
data.
Yeah,
Sure.
it's much easier for NASA to generate other than, user themselves to generate this data set,
Yes.
based on my user support experiences.
Yes. No, exactly. Exactly. So, okay, that's a good introduction here because we do have a guest speaker today and he comes from Hawaii. Greg Hamp is at the Pacific Disaster Center. How many of you have heard of the Pacific Disaster Center? Just a show of hands. Okay, a few of you, that's good. So Greg's going to talk about what they do and how they make data and web services available into their application. And so please think about questions that you might have. Greg, I assume you're on and you can hear us and you can actually, I'm going to stop sharing here and you can take over the screen and start to talk. Thanks a lot for joining us from Hawaii. Just to let you know, it's a little cooler here in Burlington and it's raining. So I hope it's better weather where you are. And you might be muted. I don't know if we can't hear you. Doesn't look like he's muted. Can't hear.
Nope. How about now? Can you hear me now?
Yep, we can hear you now.
There we go.
Okay.
Yeah, no, weather's nice. We do have a hurricane heading towards us, though. I think it's a tropical storm now. Calvin is on his way.
That's right.
But even with that, we've also been very fortunate right now because we're watching other places that are significantly hotter than we are. So there are actually people flying out here to cool down, which is a kind of a new thing for us. Let me go ahead and share screens, and thank you again for that wonderful introduction. This is fascinating work. Everything you guys are talking about is the stuff that makes up the 100% of my job, which is taking on tasks that the center assigns to integrate information. So I'm going to see if I can start with my screen. Hopefully that works. And let's give that a shot.
Yep, it looks great.
Okay, there we go. This is modified from updated from a presentation we gave to AGU last fall. And so Maggie and I have been double teaming a couple of places, but I knew that the focus here is really on integration. So I want to give I'm going to try and rip through very quickly slides and get right to the demonstration because that's what we actually want to see. It's nice and live. We can I can field questions, modify, and move around a little bit. So the basic strategic goal of PDC is fully automated global hazard monitoring for a couple of reasons. Number one, and foremost, is the fact that you can't scale manually any longer. The things that are going on, all the different types of hazard events we're trying to track happen too quickly, happen too large. So if we can't fully automate it at first, that becomes the challenge. That's the only way to actually have it sort of responsive. The three that I'll take a look at just very briefly, I think will probably resonate with what you guys have been looking at. Global wildfires, as you mentioned earlier, global flood, and then just now, we're just in a soft launch on global landslide. These three are also ones where the data itself that feeds what we call hazards on our system comes from NASA sources. We've got others, including U.S. flood and such, that are coming from domestic sources, NOAA and other forces. But on these particular ones, we're making use of what what NASA has in terms of data. What we try and do, in essence, is pull together as many threads, and I think this probably resonates very much with the ESIP mission, is pulling in whatever data it takes to bring in, modify, analyze, and eventually get it back out to decision makers. Am I capturing sort of the ESIP message as well?
Yeah, that's a good goal of the disaster life cycle clusters. Yeah.
And so, so we're using those same sort of disciplines. We feed it out to our disaster aware platform. We've got 3 instances of it. We've got a public facing disaster alert system that's a pretty good dashboard for any of for even just regular user individuals. We've got Disaster Aware Pro that we put out, and this primarily is, academics, government users, and other disaster management people around the world. And then we've got some customized solutions where we'll stand up a system within a particular country. They'll go ahead and manage the data within there and just sort of use the function of the platform. We will feed them hazards, but they can augment and supplement, so it becomes a much more customized solution for their needs. We operate with a number of partners, both in the US, international agencies, and then working with some number of national governments. And then quickly moving into global wildfire. For this, we're using the VIIRS thermal anomalies. So those arrays that are sitting up at NOAA 20 and SWOMI. And with that sort of complementing each other, the challenge there, this was probably one of our first and heaviest lifts, because we take the data essentially straight from, I'm not sure if we take it from firms or take it in another way directly. But it's essentially the same data that you'd see up on firms. And we have to go through a pretty intense process to sort of break those pixels into cohesive groupings and clusters, which then identify as expected wildfire events. And that means a lot of tuning and a lot of sort of hand-holding of the data. The goal still remains to keep that data integrity throughout the whole life cycle, so that what you serve up at the end closely resembles it. In other words, the data at the end should look like, it's mom. It should look like it's where it came from. It should be easily identifiable as from that source. The hardest challenge on this one was establishing fire perimeters. And that took a lot of sort of trial and error and training. When we presented out, we put some situational awareness products out, as well as the display up on the platform itself. We'll see that more, I think, with the when we look at the demo. For global flood, our source is Maggie's one of Maggie's teams, the model of models that outputs risk and probability for individual watersheds. You can see on this drawing, it's really that level 6 sub-basins. And we needed to, again, sort of take that data, turn it into cohesive clusters, give it some severity, and make it essentially actionable information and identifiable discrete events. So a mildly similar set of challenges to wildfire, but with the addition of really being able to work with the source team for that data. Whereas with the VIIRS for wildfire, we took the data as is. We weren't going back to the source to have them, change or modify or anything. So this was a little more collaborative with the data source, which was great in lots of ways, but it opened up so many opportunities that it also, those are some of the challenges as well. And you can see on the left, especially, the different data sets that are coming into that model of models, most of which I think are going to be very familiar to this group. GFMS, GLOFASS, DFO, I think people are very familiar with, and of course VIIRS, everyone knows. The one maybe less known is starting with a baseline risk from the global watershed risk from World Resources Institute. So that's what the MOM team did. We then took their output to turn that into cohesive structures. That's a little more behind the scenes of how those data sources were feeding in. And then this is the output, essentially the various level 6 water basins, each one assigned a different severity based on its overall probability rating, but coming right out of the model of models, and then the ability to identify and group them up. Again, we've got some situational awareness products and presentation up on this platform. And with those, it allows us to do, as we did with wildfire, some exposure, including some exposure to infrastructure and exposure to population. And then last is landslide, which, as I said, we just soft launched this past week out into our production environment. We've been working on it for well over a year. And from this, we're taking it from the LASA model, which I think some of your, some if not all of you might be familiar with. It's another NASA program, and it gives out prediction in terms of at the pixel level of the probability of landslide in a nowcast, or in some ways a little bit of a hindcast. There's some forecasting ability as well, but in particular, what it's talking about is a probability of landslide within the next 24 hours. So with that, again, sort of the process that it takes to take what is can be very wide ranging and form them into these cohesive clusters to make it into a hazard instant. With landslides, it was actually a bit simpler. They are naturally sort of forming because they much more relate to the smaller topological factors as opposed to floods, which spread out potentially in large basins. So that part of the task a little bit easier. The harder part, really developing methods for accurately portraying the overall risk. And with that, again, we've got a landslide product. We actually have a updated landslide product now that instead of impacting roads and seaports and hospitals, it actually shows roads and bridges and dams. And later on, we'll try and show the impact on potential roads within it. But you can see that it sort of forms a nice cluster actually naturally. So that made that part of the process a little bit simpler. With that, I'm going to move over to the demonstration, but I'd like to pause for a moment. Any questions on any of those three before I jump into just showing the system?
Any questions in the room? Just go ahead and raise your hand. Take a microphone.
Thank you. My name is Jenny Disson. I work for a data center and a research institute. Thank you for the examples and the list of data and the models that you're using. Just curious on how you're accessing the VIIRS data on plan via the cloud. Any feedback?
I believe, and I could double check, but I believe we access the VIIRS data right from firms. But I'm not sure if it's served out, and if it's eventually served out for the cloud, and that becomes a better or simpler method, then that's what we take in. But in essence, we're taking in the raw VIIRS data with its fire radiative potential, which is essentially heat rating that it gets per pixels. We take it in raw, the whole global setup, I think 4 times a day, and chunk through it, looking for pixels that hit a certain threshold when intersected with a certain type of land use. So for forest fires, for instance, we're looking at pixels that are burning hotter, since forest fires burn hotter. For grassland, we adapted to a slightly lower threshold. Grass burns a little cooler, but it also moves fast, and so it's a little trickier to catch it. We were missing a lot because of our threshold. But it's essentially just pulling it in raw. I don't think we've got any sort of special relationship or permission on it. I think we just pull in the publicly available VIIRS.
Okay, thank you.
And now let me go ahead and see if I can stop sharing for a moment to get to the, let's see, here we go. Come on. Just trying to close it now. Cancel that and stop showing. Yeah. There you go. 1 second. Just trying to get that to stop. There. At this point, hopefully you see, are you still seeing the screen with the application now?
No, we're not seeing that screen yet. You need to share.
Okay.
Yep.
Okay, let me go ahead and click on the proper one. There we go. And that. So
Okay,
this
now we
this
have
is so this is the PDC DisasterWare platform. And what you see is basically just a depiction of all of the disaster types that we have going on at any given moment. To show quickly what those are, we have and most of these are automated hazard generation at this point. There's a few exceptions, still extreme temperatures, drought, some that come in sort of sporadically that we still put up manually if needed, especially ones with lower cycle. But the rest tend to be are all automated. We also added just a few years back geopolitical hazards themselves. Let's see if I can get that, including some, and these are things that actually wind up impacting and affecting disaster responses. If other man-made disasters or geopolitical events are impacting it, it changes the calculus for disaster response. So putting them up on the dashboard or on the platform makes it a little bit easier. So with that, let me go ahead and take down, move most of these out of here and just bring up flood, landslide, and wildfire, and filter it down to a simpler view. So that takes everybody else out of the way, and then allows me to move into a bit of a simpler view. Our main core functions are putting up hazards, allowing the use of layers. These are all of our various layers that in our system we're able to add or subtract from the visual display. Producing map products, different briefs, and also sending out alerting to subscribers if they want to know both general alerts or also what we call smart alerts, where you define an area, anything happening in that area that that you want to be alerted to. You'll get specific alerts sending it out, as opposed to getting alerted for everything around the globe. Then additionally, the other features we have in here, mentioned a few of them, but within those layers, we've got some additional abilities just to be able to do some analysis and some localized risk analysis when we actually partner up with a country. And then just going to skip on down to bring this in. We're ending in like a minute, right?
You are.
Okay, there we go. These are landslides, and what you can see under there is iMerge, as well as the pixels that display as part of the hazard. That gives us sort of that look of it. And then lastly, for flooding that that Maggie and I worked on, we took some of the inputs, the GFMS input, the GLOFASS input also comes in as a layer. And then the ultimate watersheds that come out as well. And we put all of that together in what should be sort of our, let me see if I've got all of them. There we go, flood all layers. Try that one. There we go. And that gives you sort of both the final output from these, as well as the things that made it up. And then that gives you other products and such to be able to see what's going on. And we can bring in other products as well, just manually drop them in so that anyone who's looking at a particular hazard has got access to all those other things that might come in, reports from various sources, and ultimately sort of a single view, what we call a hazard brief. That's it. Everything else is just more detail. It could take a while digging into more of it, but at that point, any questions?
Thanks so much, Greg. I appreciate that. We do have a question in the audience, and we'll, if you can remain on the line, we'll probably
Sure.
have a discussion. Thanks.
Hi, this is Jonathan Blythe again. Thanks for the presentation. The question I have, it kind of relates to your comparison of grassland to forest fire, but what happens when your product's picking up fire, but in some cases it might be like a naturally occurring fire or a controlled burn? But is there a way to remove those, because those might not be emergencies or whatever, or
So
disasters?
that's an excellent question. So there's sort of two things. One is for controlled burns that are in fact actual, wildfire burning. We wouldn't be able to eliminate those necessarily, because I don't think we get that we get a notification on that. But we're not calling it out necessarily as an emergency. What we basically state is this is an area of which right now there is wildfire and there's forest burning. But related to your question is there's a bunch of areas that give off a heat signature, industrial areas, oil refineries, and other things that in particular would give you a false signal. For those, we actually have a global mask that we put in place that is a constantly growing database of locations that send off a heat signature, could easily be mixed with misused for wildfire. One of the checks on that to keep that from happening is, number one, we've got the mask, but even prior to that, we are only looking for things that intersect with land use that called out as either forest or grassland, and in particular, anything that interfaces close with an urban area, the wildlife urban interface zones, the WUIs, those also matter more. And lastly is a little bit of a check to just see if this is a fire that impacts any population around it. So it'd be probably pretty difficult to call it up, but we can add to a hazard if it does come out that that's a controlled burn. That's something that's easy to add to the description or add to the information, but it's not something we would catch or filter out in the automated process of detection and creation.
Yeah, and just one follow-up. That's a great answer. Thank you.
Sure.
But the mask seems really important. But when you have like fires occurring, like in California, I remember seeing them last year, over the past few years, they would start naming the fires, and the
Yes.
boundary would be determined, they'd be mapping that on a regular basis. Do you have a way to associate these features with their names?
Yes, we do. That's another excellent question. And that presented a little bit of a technical challenge, but what we came up with was a solution where we establish a preliminary boundary fire perimeter based on the satellite imagery, and that the minute or as soon as the an official perimeter and or CAL FIRE name comes out, we do bring in that data set and they're constantly comparing it. So the minute it gets a name from CAL FIRE, it gets applied to that hazard. And as soon as we have what we think of as an official perimeter, that replaces the perimeter that was preliminary from the satellite. That, by the way, was also hugely useful in training the perimeter detection and creation system, was to try it out and then compare it to what the eventual perimeter comes out. But there's typically like a day or so delay before that official perimeter comes out. A lot of times they're up in, doing that visually, from planes or from drones at this point. Did that answer it?
Sounds good. We have another question? No? We have a question online. Stand by.
Yeah, another question from Peter. Are the hazard data layers accessible via API, not the portal? Are they publicly accessible?
We do have some layers that we serve out API. We've got we established partnerships with groups, including with NASA, that they're able to reach out and pull. So it does require some authentication. So it's not public facing API necessarily. And that's just because of some of the data we actually purchase. So it goes out. But yeah, we do have some of those that are served out as APIs on a partnership platform.
No other questions? All right, great, Chad. Thanks so much. We appreciate your presentation and answering the questions. That's awesome.
Thank you. It's been a pleasure.
Yep. Okay. Let me share my screen here. Okay, so that was Greg, and it takes me to a question about decision support tools. We just saw PDC's efforts, and we're just starting up another poll here. So if you could hit that link or hit that QR code. I'm just curious as to what kind of decision support tools you might use if you have to analyze data, look at data, access data. I know some of you may be data providers, right? So you don't really use a decision support tool, but you want those tools to access your data. So what kind of decision support tools do you typically use? You can provide more than one answer. I'll go out here to the web again, and am I doing this wrong? This one? Oh, just escape out of it. Okay, there we go. Okay, so we have 2, 3 answers: GIS, weather apps. We could have a whole session on weather apps. How they work or don't work. GIS seems to be the leading. And how many of you, just by a show of hands, really want to bring in web services into your GIS system? Or do you want a number of you? And how many of you just want the whole data? You want to download the data and you want to work with the data internally? No hands. Good for you. That's a lot of work and a lot of bandwidth to download a lot of that data. Oh, this is great. California groundwater counting platform. And disaster aware, I think, that's a PDC product, I think. Is disaster aware PDCs? I don't know, maybe not.
Yeah, the DisasterAware is the PDC platform.
Gotcha.
Yep, thanks.
Sure. Okay, cool. That's 17, 18 responses. Maggie, you want to go to the next one? What data do you use or are you familiar with? So this is a free-for-all, right? What data do you use? Maybe you produce data. What kind of data is out there that you either use or produce that you think is valuable for decision makers at any level, whether it's long-term climate decision makers, short-term responders. Air quality. That's becoming so important. And these are all these data sets that are just popping up here would be great to start looking at when are they produced and when are they available, in geospatial formats. You see Landsat make a pass, or and when is that available? You see high resolution imagery from Civil Air Patrol. You see MODIS, VIIRS pass over. Any I guess NISAR, when does NISAR go up? In 2024? Yeah. Is that going to be an NRT data set, or is that going to be something that you're going to have to wait a few weeks to see NISAR?
I don't think that they're promising near real time. But there will be lower latency on some of the products, especially ones that will be related to disaster response.
So how would you define low latency, Maggie?
As soon as possible. So, that satellite data is a little tricky because it depends on the acquisition, but
Sure.
I think low latency is under a week.
Yeah. Well, that's great. We've seen a lot of great answers here. I see geostationary ABI from GOES 16 and 18. Weather service forecast, groundwater recharge, NASA and other Earth observation imagery. Trawl, what's that? Trawl. Oh, yeah. Lyme disease. When you think about it, all of these data sets that are popping up at any time can be integrated together to really give people added value to their decision-making. Rama.
I was thinking most of the satellite data, it's pretty easy to tell when and where they're going to be acquired. But you need a little more effort in coordinating the aircraft data collections. And so that needs some effort, I think.
It's interesting. We did a little experiment. Well, it was our experiment with the All Hazards Consortium. We were supporting them. NOAA flies the King Air aircraft, and they can be tasked by FEMA to do post-storm surveys with high-res imagery. And they just got a new camera. And they can land. They're starting to get some onboard processing, but as soon as they land and they upload the imagery, it's available via web services very quickly. And so I asked them for a plan as to where they were going to fly, and they provided KML files for areas where they were going to fly the next day, just so utility workers, emergency managers could get an idea of where this imagery is going to come in. So that was very, very helpful. Very helpful. It wasn't something that they're doing regularly, but they did do it to accommodate our request, and it was very helpful.
Field campaign and ocean buoy, tsunami sensors, all those data would be relevant as well for disasters.
Yeah. Exactly. Okay, this is great. Maggie, is that the last one, or do we have another one? I think we have a couple other ones.
We have a couple others. And I think that the page that you go to, or the slide that you go to will introduce the question.
Okay. All right. So there we go. Okay, so I'd like you to imagine this. Because of disaster response, it's increasing around the country and around the world. I'd like you to think of a newspaper headline. What would that newspaper headline read if we are successful in the disaster life cycle cluster in 5 years something, you know, where the disaster response landscape has forever changed by earth science data capabilities. Imagine that kind of headline. What geospatial tools, data sets, and stakeholder capabilities will need to be created to change the landscape of disaster response capabilities? What do we need? What needs to be created to see this headline in the newspaper in 5 years? The disaster response landscape has been forever changed by earth science data capabilities. What do we need?
And the poll is open.
The poll is open. You think about that. You know, seeing the answers that pop up reminded me of a hurricane preparedness summit I took part of this year. It was from NOAA's. It wasn't the weather service or the atmospheric side. It's more of the NOAA response side. And one of the things they handed out before the workshop, before the 3-day summit, was a list of resources. And it was a PDF document. They shared 40, I think it was more than 40 web portals to go to see data. 40 different web portals. Who is going to use 40 different web portals? John will. Yes, you have a question. Please identify.
John Ralph, NCEI, and under the assumption all those web portals are supported by web services, then I might in fact use all those services, not necessarily the portals themselves.
Yeah, no, that's a really good point. And that's kind of where we're headed with the disaster lifecycle cluster is web services. How can we put the pressure on data providers to make sure that they are offering web services in addition to the other science data formats that they're already offering? Because those web services can be oh so valuable in merging different agency, different types of data together. Yes.
Yeah, in a recent US opinion articles, we put together some kind of vision for a third-party shared data platform. So basically, data provider submit their data to the platform, and so everyone can share the services. Yeah, it will overcome some kind of organizational barriers. Because they only serve another data, no other data.
Yes.
How about the users, right?
Right.
Yeah,
a unified approach to data can be accomplished through web services.
Yeah, it's just like a YouTube, right? Everybody contribute, and
yes.
everybody can use.
Yes.
Yeah.
Exactly. Oh, these are great. These are great answers here. Knowledge graphs, open source and public, streaming near real time. Yeah, one of the things that we're finding is very successful with people who don't know anything about satellite data or science data and how it can help their decision making is that we provide them with subject matter expertise along with the imagery and the data itself. So we can explain what this data does, what it means, how it can be applied to their operation. All of a sudden, they're much more apt to say, okay, now where can I get this? Can I get this on my own? Or can I get it through you? Or can I get it this way? They're much more comfortable rather than saying, go to this site, you can access all this data here. It's just like throwing them into an endless loop. You know, they don't know what they're looking at. You know, most people don't even know where they live on a map. Chew on that one for a minute. You know, it's when I used to do the weather at NBC in Washington, DC, one of the things we did every time we showed a map was here we are in Washington. Touch Washington. And now here the weather is in relationship to where we are in Washington. You know, here we are in Washington. I dream about that. I haven't been on the air for 20 years. I still dream about that. Okay, let's go close that one, Maggie. We can go to the next one. Okay, what is something unique that the disaster lifecycle cluster could address over the next 1 to 3 years? So we've had a great discussion here about all sorts of things. What is it that you would like to see that the disaster lifecycle cluster, and you know, we would definitely, and we have in the past, be open to working with other ESIP clusters, community resilience cluster, the data quality cluster, a lot of clusters within ESIP. We don't want to duplicate things that are going on, but disaster lifecycle is really something that I personally would not like to see go away. I would like to see the cluster continue. We will be looking for another co-chair to replace me, so I can work on the wildfire cluster. Running 2 clusters is a heavy lift. But what's something unique that we could work on over the next 1 to 3 years? Usage-based discovery, distinction between hazards and disasters, optimism. That's, I know. It is quite depressing, right? When you get the disaster life cycle cluster on a positive note from the disaster life cycle cluster. That could be a blog, positive notes from the disaster life cycle cluster. International examples of best practices. I always thought, the ESIP ecosystem of innovation could be a great model for many organizations around the world, to have that pathway into decision makers, because so many investments are made in making little test beds, this and that. Oh, we're going to connect to this particular user. People write NASA proposals. How are you going to connect to a user? Oh, we're going to do this. And, connecting to a user is really talking to them every once in a while. It's not really putting data into their workflow. We have about 6 minutes. So we have 6, 7 minutes. Yep. Okay. Okay, this is great. I really appreciate this input. Keep it coming. The poll, I think, Maggie, that's the last one, right?
There is one last one.
There's one last one. Okay, we are a polling machine here. Okay, let's go ahead and close this one, go to the last one so we can get the okay. All right, how do you envision participating in the disaster cluster? 1 through 5, with 5 staying informed, number 1, or rolling up my sleeves, 5, and getting involved. Oh, great. I love watching these polls change, right? You can wait to the end and say, I'm going to be the last one. I'm going to make this graph change. Okay, 15 is good. I'm going to thanks, Maggie, so much. You can keep this open for a little bit longer, and we'll just go to the last slide here too. Okay, so what I'd like to remind you all, I really appreciate your attention. This is great conversation. I'm glad you asked questions throughout the session, because that's what this is. It's a conversation. I invite you to join the Disaster Lifecycle Cluster calls. We have them once a month. They happen every first Thursday of the month. The next one is on August 3rd at 4 p.m. Eastern Time. It's a standing call, happens every month. You can go to the ESIP community calendar, just Google it, and it'll show you all of the standing clusters that meet. And when they meet, you can click on that, and then you get the Zoom link and you're in. And we're going to continue this discussion and conversation over the next month or two or three. We're really going to determine what we want to focus on so we can really get our feet wet. And we appreciate all your input. And please just join us, even if you can every month, just join and say, hey, you know, I thought about this going on. What's going on with this wildfire? What's going on with these, you know, this flood event? We're working with the National Weather Service on some of their flood inundation models that they're bringing to to train the forecast offices and showing the flood extents. I'm the co-chair along with Maggie. I'd love for somebody to step up and say, hey, I want to help lead this cluster. And I'd be happy to talk to you about it. You can join the ESIP disasters email list. You can connect onto the ESIP page and look at the cluster. There's a link right there where you can connect to the email list. And then you can find notes from all of our meetings. They're listed in the Google Doc. You can access everything, who we talk to. The meeting is usually recorded. You can see the recording that we have up there, all to advance open science, opening doors to open science and decision-making so we can get more of the science data available. That's where I kind of live 24/7. And I know that a lot of data providers out there really want their data used. And there are great times to use your data. There absolutely, it fits into certain slots for needs and that decision makers need. So are there any final questions or comments or anything like that about the session? Might be able to let you go a minute early.
Dave, I just wanted to let you know that I updated my email address in the slides. So when people take a look at it, it should have the updated one.
Oh, awesome. Okay, Maggie, thank you. Thank you. That sounds great. Well, thanks so much, everybody, for participating today. Hope you enjoy the rest of the day. Maggie, thanks. And for everyone online, I hope you got all your questions answered and you felt good about participating here. So long from Burlington Online, and we'll see everybody a little bit later. Thank you.